A railroad track and a road cross at right angles. An observer stands on the road 70 meters south of the crossing and watches an eastbound train traveling at 60 meters per second. At how many meters per second is the train moving away from the observer 4 seconds after it passes through the intersection? So this is going to be a related rate problem, and we're actually going to have a couple different rates that we're going to have to deal with. The first thing I would do here is to just sort of sketch the situation. Okay, so I'm going to do it just like this. Couple keywords to pick out here. We've got south and east. Hopefully we know our cardinal directions pretty well. And I am going to call this right here the x direction, and this right here the y direction. Just kind of sticking with our coordinate plane. All right, so an observer stands on the road 70 meters south of the crossing. So there's our crossing right there, 70 meters south. So we're going to say this distance right here is 70 meters. We could say actually that it's negative 70 because we're going south, so that's the negative direction. So we'll go ahead and we'll put our negative sign there, and that's y equals negative 70. Okay, then we're watching an eastbound train traveling 60 meters per second. So that's our rate, and that's our change in x with respect to time. So we're going to say dx dt equals 60. We actually have a couple more pieces of information here. We can find this distance, right? If our train is traveling at 60 meters per second for 4 seconds, that means after those 4 seconds have passed, that train is going to be 240 meters away from our intersection. So in this case, x is going to equal 240. Okay. Let's see, dy dt. So in other words, our change in y with respect to time. And our y is our observer in this case. And the observer isn't moving, the observer is just watching. So our change in y with respect to time, that's just going to be 0. That leaves us with a couple more things to find. So we've got this distance right here, and that's kind of the distance that we're looking for. We're looking for how fast that is changing with respect to time. And I'm going to refer to that as c, just in the interest of keeping it, with our right triangle here. We've got 2 legs in our hypotenuse. Usually we call that c. And we're trying to find out what the change in that c value is with respect to time. Okay. All right, so let's go ahead and set up our problem. So we know c squared is going to be equal to our 2 legs squared added together. So x squared plus y squared, which means c is going to be the square root of x squared plus y squared. Because remember, in order to find dc dt, we have to solve for c first, or write our we have to isolate our c. So what I'm actually going to do first before we take the derivative is I'm going to rewrite my square root as a fractional exponent, because that'll make it a little bit easier when we do the power rule. So we're going to say x squared plus y squared all to the 1/2 power. Okay, so now I'm going to go ahead and take the derivative. All right, so power rule says we need to multiply by our exponent, so 1/2. So I'm going to just put the 2 on the bottom here. Then we're going to do 1/2 minus 1. So we would get x squared plus y squared to the negative 1/2, which is just the same thing as 1 divided by x squared plus y squared to the 1/2. But we need to remember the chain rule, because this is a composite function. Oops, I'm going to run out of room. So we have to, let's see, take the derivative of our inside function here, which is going to be, based on the power rule, 2x, and then it's going to be dx dt, because remember we're taking this with respect to time, plus 2y dy dt. Okay. And now we have all kinds of values over here that we already figured out at the start of the problem. So let's go ahead and fill these in, and I'm going to shift over here so I have a little bit more space. So dc dt at this specific point after 4 seconds is going to be 1 over 2 times the square root of, let's see, x squared, so 240 squared, plus y squared. Go ahead and extend that a little bit. Plus y squared, which is going to be negative 70 squared. And that's going to be multiplied by, let's see, 2 times x, which is 240, times dx dt, which is 60, plus 2 times y, which is negative 70, times dy dt, which in this case is 0 because our observer is not moving. Okay, simplifying that a little bit, 2 times negative 70 times 0, well, that's going to be 0, so I can just kind of get rid of that. Okay, then let's see, my square root, I can simplify that to 1 over 2 times the square root of, let's see, go ahead and do that out, 240 squared plus negative 70 squared gets us 62,500. Take the square root of that, we get 250, leaving us with a fraction of 1 over 2 times 250, or 1 over 500. That's going to be multiplied by, let's see, 2 times 240 times 60. So 28,800, which is going to get us a final answer of 57.6, meters per second. And that is, if we look right here,